Hi everyone, we are students from SIH 3011, Agriculture and Environment. We would like to present our findings for our mini project titled Water Management in the Agriculture Sector of Malaysia, Current Scenario, Technologies and Challenges. Without further ado, let's start with the introduction.
Water is the most important resource for agriculture because it is needed to grow crops and live livestock. In agriculture sector, water is being used through irrigation and fertigation, and in season countries, water is used for the forest control and prevent forest damage in the crops. Water is agriculture in obtained from the participation and that is rain, and fresh water that is from the river and aquifers below ground. Because the water is a great use in agriculture, there are a lot of issues that come from it. First, water scarcity. It is mean due to the climate change, where in the 2015 in extent that 2/3 of the world population will face water threats. Also, the over-exploitation of groundwater and surface water can distribute and recharge and discharge of the fresh water, leading to water scarcities. This is a problem of the agriculture sectors, and a study done Africa from the water scarcity's negative impact crops yield and the risk in global temperature case water streets, and which lead to the declines in the agriculture economic. Besides that, flooding is also a problem in the agriculture sector. Flooding is a case by increased participation and the freshwater level due to the seasonal or climate factor. It may also be case by using farmer island and the retention area of flooding water management. Flooding adversely damage the agriculture sector directly and indirectly. The direct impact of flooding will cause a drop in yield production and damage to soil, machinery, and infrastructures. Indirectly, they will cause by delay of the supposedly supply and demand between the farmer and the customer, case by business interruption. With all this issue on water and agriculture, what is being done to overcome them? The United Nations addressed that these water issues in 16 Sustainable Development Goals, for example, SDG 2, which maintain about sustainable food production system that maintain the ecosystem in the changed climate while increase farmer production and income. Also, SDG 6, which is addressed on the ensures water security through the better water use, the efficiency in the all six sectors: ecosystem, water restorating and improvement of water quality. How about Malaysia? How about treating the issues? Malaysia release is 12th Malaysia plan, which them Team 3 aspects of better water resource management to ensure water security through the potential of integrate the water resource management. Also, the National Agri-Food Policy 2021 to 2013, Malaysia come out with a policy trust on the smart agriculture and the sustainable agriculture plans of the efforts using the resource. And with that, the problem assessment of the real group study is how to exactly the water being managed and conserved in Malaysia right now. To answer the problem, we come out with three objectives. First is to understand how the Malaysia government manages their water resource of the agriculture sector. Secondly, to learn the technology used the farmer to help them with the water conservation while it reaches good harvest. Thirdly, to find out the challenge faced by the Malaysia struggle in the agriculture sector in water conservation.
Therefore, to understand our first and third objective, we went to Bahagian Pengairan dan Saliran Pertanian (BPSP) to interview their Senior Assistant Director, Engineer Wan Noorul Hafilah. Here is what we got from the interview. In Malaysia, water resources for agriculture are obtained from rain as the main source. Rivers and catchment basins are also used to supply water for agriculture. Catchment basins can be categorized into two, which are man-made and also natural ones. Man-made catchment basins are dams and detention ponds, while natural ones are like lakes. The water supply for agriculture in Malaysia varies depending on the type of crops. For instance, small-scale farming for vegetable does not require intensive water usage, thus they only rely on rain or supplied water from sprinkler or drip systems. On the other hand, for commercial agriculture like paddy plantation, water supply is often from dams as paddy requires flooding for its growth. How water can be harvested, stored and supplied in Malaysia could be through the farmers' own initiative to build a catchment basin on their farm to collect rainwater, or through the government's initiative to build dams and infrastructure for water distribution at agriculture areas. Dams also act as a rainwater harvesting system to store rainwater for future users and prevent them from running off into water bodies like river or sea. Currently, there are 104 dams around Malaysia with various purposes. It could be for flood prevention in lowland areas, hydroelectric generation, recreational purposes, and of course for agriculture users. The management and operation of these dams are under different authorized bodies, such as those for agriculture are handled by the Department of Agriculture, and those for flood prevention are handled by the Department of Irrigation and Drainage. Besides that, the government is also in charge of building infrastructure for water delineation from rivers to agriculture areas using money allocation for agriculture and as a way to invest in food security. The water distribution in Malaysia is dependent on some factors like weather pattern, land topography and land use, which can also serve as the problems in water management for the agriculture sector. Inconsistent weather patterns can affect the quantity of water being stored. Malaysia experiences a lot of rainfall, but it is seasonal. Problems arises when water is not managed properly during drier seasons when water can be scarce. The water levels in dams can be reduced significantly during drought season, causing low water input for agriculture areas and affecting the harvest. Thus, how the government handle this issue is by proper rationing of water supply for all the other sectors to ensure availability. However, more focus is given to the domestic sector. Rationing is also done while we wait for rainfall to top up the water loss, and when it rains, it is not advisable to use the rain in the dams, but instead utilize the rainwater itself straight away. Initiatives on cloud seeding can also be done, but could be inefficient as water cycle and wind movement can cause rainfall and unpredictable areas. Apart from that, farming practices like using adequate water at only the appropriate growth stage of rice cultivation are also done as a way to conserve water during dry seasons. Land topography can also affect how we manage our water. When flooding occurs in lowland areas, how do we flush out the water? Dams are typically built upstream, so it is inefficient to pump storm water from lowland to the upstream. The Department of Drainage and Irrigation tackled this problem by flushing the storm water to lowland dams and those near the sea. But there is another problem when sea levels are high and the storm water cannot make its way into the dam. Instead, more water from the dam is expelled out. To tackle this, the government had built catchment and storage areas to hold the floodwater while waiting for the sea level to drop before flushing them into the sea. For instance, the Smart Tunnel, which is a mega water holding storage system to hold floodwater. Another challenge of water management is regarding the change of land use. Due to globalization and demand, a lot of natural areas are being turned into cities and urbanized areas. This can disturb the natural ecosystem service of water absorption by soil, as soils are being cemented, tarred, and have buildings. Thus, these cities and urban areas are prone to flooding as water can't make their way into the ground. And because water movement is a continuous cycle, there needs to be a way to ensure the water received in an area before a development is more or less the same with the water that can be stored by an area after the development. This way, flooding is less prone to happen and there is no need to flush large amounts of water into dams or rivers after a heavy rainfall. This can be done by constructing rainwater harvesting or detention ponds in cities and urban areas. These ponds can also be a water source for domestic purposes. There are also other problems in managing water for the agricultural sector. For instance, infrastructure problems, that is crackings and holes found on old water infrastructures that can cause wastage of water that should be provided for agriculture but instead is lost and wasted. This causes the intended supplied water to be less than what is received at farms. Another problem is due to pollution. The agriculture sector can be polluting to the environment, especially if the farmers use chemicals excessively and improperly. The chemicals can run off or seep into groundwater as pollutants. This causes further damage to the water resources in that area. Thus, the government tackled this problem by educating farmers to give awareness on proper use of chemicals and the use of only certain certified chemicals. We also asked engineer Wan Noorul Hafilah about the current water resource in Malaysia as compared to before. Let's see what she has to say.
Okey, sekarang ni kita nampak pattern ni kita lebih baik menguruskan air. Sebab apa? Kita sekarang ni kita perlu lebih banyak makanan. Kan kita perlu lebih banyak hasil pertanian. Kan dengan jumlah hujan yang sama. Kan dan kita dapat hasilkan lebih banyak keperluan untuk pertanian dengan jumlah population yang kita semakin meningkat. Kita dah dapatlah. Sebab kalau kita tengok tanpa air pertanian ni tak boleh kita kata tak inilah kan food security dia kena ada water security dulu kan dengan adanya air yang mencukupi yang kita dapat hasilkanlah pertanian yang baik dan saya nampak itu adalah indikator kepada kita mempunyai air yang mencukupi efisien untuk kita bertanam kita masih berada di tahap yang bagus kan.
Moving on, to meet our second objective, we conducted a literature review on the current technologies being used in Malaysia to help with the water management and conservation. These are our findings. Technologies for water management in the agriculture sector are widespread. It is used by the government agencies to manage their water, private sectors to help them with water conservation, and academics to further understand the feasibility of these technologies. Muda Agriculture Development Authority (MADA) is a Malaysian government agency in charge of advancing the national paddy industry to be more modern, efficient, sustainable and competitive. They use a few monitoring stations around the Muda area, which consists of rainwater monitoring stations, water level monitoring stations and also irrigation outlet opening stations. All these stations will be monitored and their real-time data is sent to a telemetry station which allows the government officers to monitor the changes in water resources remotely. This helps them efficiently manage the water and for flood routing in the Muda area. Besides that, there are also engineering-based companies in Malaysia that provide services using technologies for water conservation. For example, Wastetech Engineering Malaysia provides irrigation solutions for farmers through drip systems and sprinkler systems. The drip system provides water for crops directly to roots and it is done in a controlled manner. The sprinkler system mimics rain because water is being forced through a nozzle and sprayed at a precise location of the farm. This reduces water wastage and runoff. These two systems are good examples of technologies to supply water for smaller farms like vegetable farms as they don't need intense water supply like those for rice or oil palm plantation. Other than that, there are also a few smart farming systems provided by Regal Tech Group. For instance, the IoT Smart Fertigation System monitors the nutrient levels in the soil and automatically dose nutrients precisely. This way, water and nutrients provided are controlled, accurate and not wasted. Research for agricultural wastewater treatment is very extensive in Malaysia. The purpose of treating wastewater is to ensure the discharge into water bodies is safe and does not degrade the environment. Also, some wastewater are recycled to be used back in the sector. An example of research that uses engineering techniques to treat agricultural wastewater is using membrane separation technology to treat the pollutants from palm oil mill effluent. This technology uses films or membranes created using various materials with characteristics to filter off the desired pollutants. Also, biological treatments are favorable due to the environmentally friendly process and a form of green technology. For instance, there is a research being done to phytoremediate palm oil mill effluent through constructed wetland using aquatic plants like water hyacinth and water lettuce. Constructed wetlands can help to remove organic pollutants, nutrients, solids and trace metals in agricultural wastewater. In addition, researchers also use bacteria Acrobacterium species to bioremediate agricultural wastewater. These species of bacteria can survive in anaerobic condition and helps to lower down chemical oxygen demand and ammoniacal nitrogen, and at the same time can secrete lignocellulosic enzyme for further palm oil mill effluent treatment. Furthermore, we had an interview session with a local aquaponic farm owner to find out his water management practices and challenges that he faced. Unit Farm is managed by Mr. Yaw and he practices an aquaponic urban farm. He grows various types of vegetables like milky pak choy, choy sam, Brazilian spinach, Okinawa spinach and more. Apart from that, he also raises red tilapia fish, which he also sells when they have reached maturity. Mr. Yaw started his aquaponic farm back in 2019 as a way to eat clean, provide job opportunities for his family and to start a business. The aquaponic system that Mr. Yaw uses is very much dependent on his tilapia fish. The fish produces waste, which causes high concentration of ammonia in the tank. Then, the bacteria living in the tank will convert this ammonia into nitrite and nitrates, which is beneficial for plant growth. The tank water is then pumped out from the tank and into a filter system where sediments like the fish waste and leftover fish feed is filtered out, and the waste and the water is pumped to the vertical farm tower. Water will then flow down the tower following gravity and nourishes the crops grown on the farm with water and plant nutrients. Excess water is further collected at the bottom of the tower where Mr. Yaw puts leca balls to allow more beneficial microbes to grow. The collected water around the leca ball may have excess ammonia, which is further turned into nitrites and nitrates before flowing back into the fish tank and continuing the cycle. There is also an intermediate bulk container IBC tank to wash his filter system that contains filter beads, and he also uses a rainwater harvesting system to utilize the rainwater for washing. Because Mr. Yaw's aquaponic farm is dependent on nutrients in the water, what did he do to kickstart his farm during the early stage and how did he maintain it? Let's hear it from Mr. Yaw.
We normally the ammonia in during the initially the setup.
In the setup you did?
Setup, we will every week we will go and check in the water quality. We will check the pH,
pH,
ammonia, and then the NO3 nitrate. Okay, so if because when you start the system, you have a very less of bacteria. So during the time, then the NO3 very less, but the ammonia a bit higher. But when the bacteria start working, normally after 1 month, they start working, then you see the ammonia is contained very low. Then the NO3 nitrate increasing.
NO3 nitrate increasing.
Then you plant the veggie, then keep on circulation. So this one water normally we no need to change the water.
Oh, I see.
This one already almost 3 years. Didn't change.
No change water.
Didn't change water.
Do you add water?
Yes, add water.
Because already used for the vaporize. Yes.
So normally water no need to change. Then your fish will be die. Sometimes it's because the ammonia very high. And your fish will die. But because this one the ammonia is very low, so it keep on circulation. So I no need to change.
I see. Because water is being continuously being recycled in the system, no wastage of water is experienced by Mr. Yaw. However, he does need to add in more water because the water can be lost through evaporation and transpiration. Because of this, Mr. Yaw only had to pay a small amount of water for his bills, while the heavier pay is on electricity. This is one of the challenges of running an aquaponic farm, as it is highly dependent on electricity due to the pump needed to run for 24 hours. Therefore, electricity bills can be higher and consistent electricity availability is important to run this farm. Finally, to conclude, these are all of our findings in regards to our 3 objectives.
In conclusion, water is an important natural resource to be managed popularly to ensure agricultural productivity and food security. The way water is being managed by the Malaysia government involved a few answers activities that its Department of Agriculture and the Department for Irrigation and Drainage. How they manage its important natural resource is by the constructing infrastructures such as dam, smart tuner, and the catchment business. They also conduct retentioning and smart use water to ensure unbelievable of the old skirt and the long proved to time when water can be used scarce. The Malaysia government also use some technology which include smart irrigation system and the water monitoring center and the commercial farmers. And part of that, there are also other available technology of the water management in Malaysia, like PRIS and the SPRI system of immediate run out of ensure water conservation. Also, IoT smart fertigation system of the PRIS and plantation of the water and fertilizers. Also, there is extensive research being done come out with new methods of the touring agricultural wastewaters. Also, it can be the recycle. Some example is of the treatment use biological organism activity carbon and memory process to remove wastewater. Aquaponic system is another example of the water conservation technology that ensure agriculture productivity while not irrigating to water environment. Its aquaponic system use very less water and the water is not being wasted in the process. However, it poses a challenge on high electricity usage and the pull into use of the 24 hours. Another problem is the price of the aquaponic vegetable, which is maybe higher than the other traditional roots vegetable. In addition, the Malaysia government also face a challenge in managing water of the agriculture, which is due to the inconsistent weather pattern, land to phosphate, and land use, infrastructure problems, and water pollution.
Before we end the video, we would like to thank Bahagian Pengairan dan Saliran Pertanian BPSP as well as Unit Farm for their cooperation to finish this mini project. Here is our list of references and thank you for watching.